Okay. All right. Let's critique it. So just remember what we said yesterday. What's this thing called where it's an integral where it doesn't have any limits? It's called an indefinite integral. And the answer to an indefinite integral is a function. Okay. So this we're saying is equal to this. Do we agree? Add 1 to the power, divide by the power. Here, we can check it. What's the derivative of this? 3x minus 4. So this one's good. Okay, nice job. Okay, what about this one? Final retail answer here is 2 times the square root of t cubed divided by 3 plus the constant. We can see that it was rewritten here. Just a side note. We always have to tell what variable that we're using, okay? Because this, by the way, the title of the book is Calculus of a Single Variable. Calculus of a Single Variable, that's first semester. After first semester, you go to multivariable calculus, okay? That's when this really matters a lot, okay, because of the different variables. All right, anybody else get these answers? No? Okay, so who's right? You get that? Well, then it's right. Well, okay, I'm going to go through the process. What I know is you add 1 to this power, so 1 plus 1/2 is 1 1/2, which can be written as 3/2. So t to the 3/2 is good. Then I got to divide by 3/2. And dividing by 3/2 is the same as multiplying by 2/3. So that's good. And then this is the square, the bottom is the root, so it's the square root of t to the 3rd power. So this looks good too. Okay. All right, the next one. Anybody else get that? Okay, so I'm just going to rewrite this so you make sure that you see. This is exactly how I would do it. I'd say, well, this is the same as 4x to the negative 4th, the integral 4x to the negative 4th dx. I'd rewrite it like that. And then I'd go here and say, okay, this is 4 times x to the negative 3 divided by the negative 3, which this is equivalent, plus the constant. And then just make sure, because in the AP test you don't know whether or not they're going to have positive or negative exponents, make sure that you know that you can write this in multiple ways, this being one of them. Okay, so make sure that you can do the algebra. You can manipulate these things as we need to. Okay, all right, and the last one, not a whole lot of work here. The integral here of the sine of theta is the negative cosine of theta. Okay, and this constant here, does it make sense? If I wanted to rewrite this, I could write it like this. You know what I mean? And then the answer to this thing is the negative cosine, so that's why it's 6 times negative cosine of theta plus our constant, and then boom, we can write it like that. Make sense? So for all of these problems, you just have to stop and think, do the math for each one of them. And you just got to do practice. So I can't stress enough. Page 255, this is your chance to get better at it. No.
Well, I was going to say I might go over it tomorrow for questions on homework, but in the homework, like, there's like integrals with the chain rule in it, and I don't know how to.
Okay, can you give me one?
Yeah. I know what I've almost
x squared plus what?
Number is x plus 1 divided by the square root of x, number 27.
We have to do it.
Yeah,
It's the same concept.
Maybe that's
okay. So by the way, so if you were, let's pretend we weren't integrating, but we were differentiating, what rule would come to mind? Quotient rule, right? Because you got a quotient. Okay. This one actually is doable, and we don't have such a thing right now as the quotient rule for integration. But let me show you how you would handle this one, or handle one way to do it. I call it the divide and conquer. Okay, because whenever I have a fraction, I can take each of the pieces of the numerator and divide it by the denominator. It's the way fractions work. Okay, so this is the same as x squared over the square root of x plus x over the square root of x plus 1 over the square root of x dx. That's how fractions work. Okay, and then look at this. For each one of these, isn't this x to the half, x to the half, x to the half? So I can actually rewrite this as x to the half for each one of those, and then I can subtract. There's an x to the second on the top, there's an x to a half on the bottom. So this means that this thing right here is the same as x to the 1 1/2 or x to the 3/2. Because it's 2 minus a half. Then this one here, this is really x to the first minus, or divided by x to the half. So I can just subtract 1 minus a half. This is the same as x to the half. And then this one right here, we recognize that 1 over the square root of x is 1 over x to the 1/2, which is the same as x to the negative a half. And then just boom, you take it from there. Okay? Now, just so you know, there is a thing that handles the chain rule for integration, and that's actually in the very next section. Actually, 2 sections. Okay, so we're going to handle that next week. Okay, alrighty. Backboard. Take down the notes, and then we're going to do some. So the topic of the day is solving differential equations. So the definition of a differential equation is that it's an equation that contains a derivative. And the action to solving a differential equation means to find the actual function, including c, whose derivative is the differential equation.
This is still part of 4-1.
Yeah, this is still 4-1. 4-1 continued. I'll let you get that down before I go. I don't know if you guys ever experienced this, but when I was a student, I always hated it when the teacher would write up on the board like that, and then while you're trying to copy the notes down, they're saying all this other stuff. And it's like, I'd walk out of the room and I have these notes, but I don't know anything about what they mean because I couldn't listen to the teacher at the same time I was writing. So I try to make a habit of not talking when you're taking down stuff. And that's why I don't expect you to write down everything that I say. You should have when you finish this class, you should have a book of notes that just kind of are important to you. Things that I've said. It shouldn't be a duplicate of everything that's ever been said in that class. Remember that for college, too. take down the important stuff. Jot down notes into your notebook, not copy everything. Okay, so let's go ahead and get started. So to take a look at this, a differential equation. This actually is a differential equation. It's a differential equation because it's an equation and it contains a derivative. Okay? That's what makes it a differential equation. This right here, notice the key is that its f of 4 is equal to 2. F of 4, not f prime. F of 4 is equal to 2. This is called an initial condition. An initial condition is a secret message that allows you to find the value of the constant, c. Okay? I'm going to show you how we do that. So our goal, solve the differential equation. Well, to solve it means I got to find f of x. So when I'm all done with this, I should have some function. This is going to be the answer. Therefore, f of x is equal to, it's the function, and its derivative has to be this, and this also has to work. See that? That's the connection between these two things. So let's stop and think here. Does everybody agree that f of x is going to be equal to the integral of f prime of x dx? Would you agree with that? If you integrate f prime of x, you're finding the antiderivative, so it's equal to the f of x. Okay? So that means that if I want to find the function, I just have to integrate the derivative. The 1/2 x minus 1 is my derivative. So if I integrate that, I'm going to get the function. But I'm also going to get that c. Remember? Like all those ones up on the board? I'll have the c. Okay. So, all right, let's do it. What is the integral of 1/2 x minus 1? Try to do it in your head. Give me a final answer. Good. 1/4 x squared minus x plus c. Everybody agree with that? That's following the power rule that we started learning yesterday. Okay? Now, is this the final answer? No, because to solve the differential equation means to find the actual function, including finding the c value. Okay? So, how do you suppose we figure out what c is? Plug in the initial condition. So, with f of 4 equals 2, that means that x equals 4 and y equals 2. Correct? That's what the 4 and the 2 mean. So, that means that I can write this as 2 is equal to 1/4 4 squared minus 4 plus c. See what I did there? You take this puppy right here, and this is the y-coordinate when x is 4, and so it's 2, and then you just put a 4 in for every x. Now we just got to do the math, figure out what c is. So what do I got here? 2 is equal to 4 minus 4 plus c. Where do you get that? So this means that c is equal to 2. Right? Which means, therefore, what's the final function? Well, the final function is 1/4 x squared minus x plus 2. And that's your final answer where you solved the differential equation using the initial condition. Make sense? Okay. Now, by the way, let's just verify this. We'll test it. What's the derivative of this function? You get 1/2 x minus 1. That matches, right? Okay. If you plug a 4 into this, plug a 4. Okay, so 1/4 4 squared minus 4 plus 2. What does this give you? It gives you 2 because that's what f of 4 is supposed to be equal to, because that's what we were told. Okay? That's how you can match. That's how you know if you solved it, if it matches everything that was before. All right, let's do another one.
Oh, didn't go. There it goes.
There he goes.
There it
Say
goes.
hi, Jamie.
Hi, camera.
Okay, you do this one. Okay, you try doing the same thing as I just did. And take it from here. G prime of x is equal to 6x squared. And g of 0 is equal to negative 1. Okay, just do what I did. Solve this differential equation. That means solve it. Tell me what g of x equals. All right. Can we go through it? Okay, here we go. G of x is equal to the integral of 6x squared. That's where you start. So that's equal to, let's see, 3, that's 2x cubed plus c. Okay, so that's the integral of this. That's g of x. But then now I'm going to find the c value. So this says g of 0 is equal to negative 1. So this means negative 1 is equal to 2 times 0 cubed plus c. This tells us that c is equal to negative 1. Therefore, final function is 2x cubed minus 1. How many people got that one right? Okay, good. These are the steps that you follow. You integrate, you use the initial condition, and then you go ahead and solve. All right, let's do number 3. What's different about number 3? Double integral. Look at f double prime. Okay. Now, it actually follows the exact same format. So, does it make sense that, all right, if I want to proceed on this one, I have to integrate the sine of x, and that's going to give me the first derivative. Because it's all about going one level up. The antiderivative of the second derivative is the first derivative. Okay. All right, what's the integral of the sine of x? Negative cosine of x plus c. So that's what f prime of x is equal to. Okay. And the initial condition for f prime is that f prime of 0 is equal to 1. So this is a 1 is equal to negative cosine of 0 plus c. Oh, there's that unit circle again. What's cosine of 0? 1. Okay, so this means it's 1 is equal to negative 1 plus c. Therefore, c is equal to 2. Okay, therefore, f prime of x, the first derivative, is equal to negative cosine of x plus 2. Right? But now we just have to repeat it. We got to do it all over again for the first derivative. So f of x is equal to the integral of the negative cosine of x plus 2 if we integrate the first derivative of f, we get f. It's the antiderivative. Okay, what's the integral of the negative cosine of x? Negative sine of x. So it's negative sine of x plus integral of 2 is 2x plus the constant. So that's your function. And then to find the constant of integration, we use the fact that f of 0 is equal to 6. So this means 6 equals negative sine of 0 plus 2 times 0 plus c. Sine of 0, 0. 2 times 0, 0. So that means c is equal to 6 here. Okay. So therefore, final or retail answer is, to solve the differential equation, we're solving for f of x. It's equal to negative sine of x plus 2x plus 6. And there we go. Does that make sense? Okay. Now, let me show you something kind of clever. Okay. This is what we're doing here. I think I'll do this on the backboard. Look, read that definition again, and read that to solve, and see if that makes sense for what we did for the last 10 minutes. That make sense? That's exactly what we're doing. We're solving the differential equation. We're finding the actual function, including the c. Okay, let's recall some physics. So the position function, when you have something that you're launching in the air, goes back to our potato gun thing that we did at the very beginning. There was this height function. It was S of t. Anybody remember that? The full-blown generic formula? Page back in your notes. Go find it. Way back in the beginning. I want the generic formula. What do you got?
Negative 16 t minus, in parentheses, negative 16, then in parentheses, t minus, I think that's a 4.
All right, I want a generic one.
Negative 16 t squared plus h of
Okay. Plus h what?
sub o.
H sub o. Anything else? This is if you drop something. Okay. There was one if you launch something. Yeah.
We won't have gt squared.
There we go. Okay. 1/2 gt squared
Plus sine of theta.
sine of theta
V subscript t.
b sub 0
Sub 0 t.
t
Plus the initial height.
initial height. Okay. This is your generic formula. This actually tells you the height of any object in a windless environment, airless environment. You can tell the height of it launched at any velocity, from any height, at any angle. Okay, so it's pretty cool. Now, we're going to use the modified version of this that doesn't have the angle part of it. I'm going to show you something. So, S of t is equal to 1/2 gt squared plus v sub 0 t plus h sub 0. This is the one I want to work off of. Okay. Now, this works if you're launching it straight up in the air. Okay, tells you how high it is if you're shooting it straight up. And that's because the angle with relative to the ground is 90 degrees. What's the sine of 90? 1. So that's where this drops out, because it's 1. Okay, as soon as you change the angle, then you can use this formula. But this is what you have. This tells you the height of the object at any given time. G is the acceleration due to gravity. Okay, in your physics class, if you use meters, what is it? 9.8. And what are the units? Meters per second squared. Okay, that's acceleration. And then we recognize that v sub 0 is the initial height, or is initial velocity, how fast the thing is being launched out. And the height is how high above the ground that you are. Okay? And this tells you, S of t tells you your height above the ground of the ball at any given time. So where does this come from? And not only that, this is what's really cool. When Galileo's the one who figured this out. Pretty cool. Okay? And he said this, pretty miraculous. He says, you know what? It doesn't matter if you're on the moon, or if you're on Mars, or if you're at Jupiter, it works. The same formula works. G just happens to be the gravity that you're on at that time. Okay? And now, you were taught in physics that gravity is a constant, right? It's always the same pull. Now, it does matter where you are on the Earth. It's not actually truly constant. It does matter where you are, but we use 9.8 in general. Okay? And then if you go to the moon, it's a different gravitational constant. Okay? Watch this. So, would you agree that the acceleration on the planet Earth is 9.8? Okay? We'll just say that that's what it is. Now, some people use the negative 9.8, some use the positive, but we'll just use the positive 9.8, okay, because it's always pulling. I wonder if we can compute the velocity function off of this. If you know the acceleration, can you figure out the velocity? What do you have to do? You've got to find the antiderivative. Okay, so that means, so I know this, so that means that the velocity function, using the notation that we have here, isn't it equal to the integral of the acceleration function? Yeah. And what's the acceleration function? It's 9.8. Right? So, okay, all right, need some help here. That means that the velocity function is 9.8 t plus some c. Right? Now, wait a second. If this is the velocity function, then this constant is the initial velocity. It's when time is equal to 0, what's your velocity? And we know that the initial velocity, we can say that v of 0 is equal to v sub 0. This means initial velocity. When time equals 0, it's the initial velocity. So with that in mind, we can plug in this and we can say v sub 0 is equal to 9.8 times 0 plus c. Doing exactly what we just did over there. Okay, so that means we can wrap up and write a function for velocity. That means that v of t is equal to 9.8 t plus v sub 0. Everybody agree with that? I'm not doing anything funky that you're not believing, right? That's so important that you see that. Well, wait a second. If I know the velocity function, I can actually figure out what the position function is by integrating. So that means that I'll use s of t as the position. Isn't that equal to the integral of the velocity? That's the position function. That's what it means. But wait a second. That means that it's the integral of 9.8 t plus v sub 0. And some of you are seeing where this is going, right? Oh boy, I got to do this integral. So that means that s of t is equal to, okay, what's the integral of 9.8 t? 9.8 t, that's really confusing. What's the integral of 9.8 t? So it's 4.9 t squared, right? 4.9 t squared plus, this is the constant, it's a number, so it's v sub 0 t plus that doggone constant, right? But wait a second. That c would be the initial height, because that's a height function. So that means that s of 0 is equal to h sub 0. And if you do the math, plug in the t's for all zeros, you get this. You get that s of t is equal to 4.9 t squared plus v sub 0 t plus h sub 0. You see it? But wait a second. If we said, let's not use Earth let's use any planet, wherever, and we just say that it's equal to 8. Let's say that it's equal to G. Right here, it's 1/2 GT squared. Isn't that cool? All right. Have a good day.